Okay, so this is going to cover the last 2 pages of the study guide. So for number 1, numbers 1, 2, and 3, they're talking about the mid-segment of the triangle. So it told us here that DE and DF are both mid-segments. So they want us to first find the length of DB. Now remember, the mid-segment is created by connecting 2 midpoints. So if they're telling me that AD here is 10, then I also know that DB is also 10 because D is the midpoint. So the answer to number 1 is 10. Then to find DF, remember the mid-segment is always going to be half as long as the side that it's parallel to. So since the side that it's parallel to is BC, and since BC is 26, to find DF, I just have to do 26 divided by 2, and I get 13. And then here it says, what can you conclude about EF? So EF, if you connect these 2 midpoints, you can also see it's going to be a mid-segment as well. Remember, every triangle has 3 mid-segments. Then for number 4, 5, and 6, this is where we talked about perpendicular bisectors and angle bisectors. So remember that whenever a point is on a perpendicular bisector, so for example, point V here is on this perpendicular bisector, and I can tell it's a perpendicular bisector because of the right angle and the 2 congruency marks. So I know that any point on a perpendicular bisector is going to be equidistant from the endpoints of the segment it bisects. So to find the answer to number 4, which is going to be 2, it says we're going to set 2x plus 11 equal to 8x minus 1. Doesn't matter which side you put, the 8x minus 1 or the 2x plus 11. So I'm going to subtract. I'm going to add the 1. 12 equals 6x. Okay, so then I'm dividing both sides by 6, and I get x equals 2. And the reason why I know that is because, like the congruency marks I added here, SV is congruent to UV because it is on that perpendicular bisector. Next, number 5, I can tell that this angle here, PSR, has been bisected because of the congruency marks. So this tells me that SQ is the angle bisector, and I know that any point on that angle bisector is going to be equidistant from the sides of the angle it was bisected. So I'm going to set 6x equal to 3x plus 9. I'm going to solve for x. By subtracting 3x, I get 3x equals 9. Divide by 3, and x equals 3. Then for the next one, same thing, but this time I can see that these segments here are equidistant from the sides, and I know they're a distance because of the right angle. So when I have a segment that's equidistant from the sides of my angle, I know that this angle HGK has been bisected. So I know that this angle here, the 5x minus 4, is going to be congruent to the 4x plus 3. So I'm going to set 5x minus 4 equal to 4x plus 3. I'm going to go ahead and subtract the 4x. X minus 4 equals 3. Add the 4, and x equals 7. Number 7, it says in exercise 4, is point T on the perpendicular bisector of SU? And the answer would be yes, because remember, this is a line and it's going to keep on going. You could also have realized that this is an isosceles triangle, and then you would have known that it was equidistant from the sides. For number 8, in the diagram at the right, the angle bisectors of triangle XYZ meet at point D, and it wants you to find the length of DB. So for this one, you're probably not going to get a question like this, because in order to find the measurement of DB, which is here, I would need to use Pythagorean theorem. Now, I know it's a skill taught in middle school, but we haven't officially learned it, but that's what you would need to do here, because what has been created here is a little right triangle. So I have a little right triangle right here, and 25 is the hypotenuse, and 24 is a leg. So all of these blue lines that are here, this one, and this one, are all equidistant to the sides of that triangle. So once I find DC here, I pulled this triangle out. As soon as I find this measurement, then it'll apply to DB, which was what it was asking me to find. So what I need to do here is Pythagorean theorem. So I'm going to be doing a squared plus b squared equals c squared. My a squared will be this x. So I don't know it. So I could put x squared here. My b squared, my b is 24. And remember, the hypotenuse is always the biggest side. So now I need to go ahead and multiply. So 24 times 24 is 576. 25 times 25 is 625. And then I need to subtract. And I get 49. Square root it, and x equals 7. So this little piece right here is 7. So then all of these other blue ones are also 7, because they're all equidistant to the sides. So the answer to this is 7. For the next one, it says in the diagram at the right, P is the centroid. So this is the 2/3, 1/3. Okay, so remember, for the distance from the vertex to the centroid, for example here, LS. So LS is the length of the whole thing. And coming out of the vertex, going to the centroid is the 2/3 part. And then from the centroid to the side is the 1/3 portion. So that whole thing equals 36. So to find PL, I know what I can do here is take my centroid, my LS, and multiply it by 1/3, and it's going to give me PL. So 1/3 of 36 is going to give me 12, and that's the length of PL. And then to find the length of PS, I'm going to do the same thing, but it's 2/3. So 2/3 LS equals PS. So 2/3 of 36 equals PS. So PS equals 24. You could go ahead and simplify diagonally here, make this a 1, make this a 12, and then multiply. Now, remember, these two numbers that we get here for PL and PS, when you add them back together, they need to add up to be 36, or you've done something wrong. For number 10, now it's going to be talking about another one, another piece of it. So it's TP this time. TP is here. It's from the vertex to the centroid. So this is my 2/3 portion. And this is my 1/3. So TP is 20. So now to find the other pieces, I know that I can go ahead and to find TJ, which is the whole thing. And then I have, so 2/3 of TJ is going to equal PT. So they gave me, or let me reverse it, TP. They gave me that, and that was 20. So all I'm going to do here to solve is multiply by the reciprocal, simplify, and the length of the whole thing, TJ here, is equal to 30. Now to find the length of PJ, since I know the whole thing, I could just do 30 minus 20 and get 10, and that would give me PJ. Or I could do like I did before, 1/3 of TJ is equal to PJ. And since I just found TJ, I could just do 1/3 of it equals PJ. So 10 equals PJ. Multiple different ways once you find some more of the pieces. All right, and then number 11. This time they're giving me JR. JR is over here. So they're telling me that JR, is 25. So I know J is a midpoint. So JS is also going to be 25. And then to find RS, the whole thing, you just add 25 plus 25, and that is equal to 50. Because this centroid, to form it, it goes from the vertex to the midpoint of the side across from it. Then number 12, it says, is it possible to construct a triangle with side lengths 9, 12, and 22? If not, explain why not. So remember, on this one, all you need to do is take the two smaller numbers and add and subtract them. So you could do 12 minus 9 and get 3, and then 9 plus 12 and get 21. And because 22 is not fitting in between that sum and difference, this answer is no, because the third side has to be greater than the difference but less than the sum, and 22 will not fit into this inequality. So this is why number 12 is no. For number 13, it says in triangle ABC, so let me go ahead and sketch this triangle. And again, you don't necessarily have to draw it to scale. So A, B, C, and it says AB is 36. It said BC is 18, and AC is 22. So this is number 13. So it says list the angles in order from smallest to largest. So remember, the largest angle is across from the largest side, but they want it from smallest to largest. So my smallest side is the 18. So that's going to be angle A is the smallest. Then the next biggest side is the 22. And that would be angle B, which is across from it. And then lastly, the largest side is the 36. And the side across from that is the C, or the angle across from that is C. So from smallest to largest, it's angle A, angle B, angle C. And then number 14, this is where we have to do the triangle inequality theorems. So here they're telling us that angle JKM, so this angle here, is going to be greater than angle LJK. So if it helps you to put numbers, maybe you could say this one's 40 and this one's 30, just so you have to see which one's bigger or smaller. Just pick a number that's larger than the other one. So then you can see that the side across from the bigger angle is going to be JM. So this is why, or MJ is going to be the larger side. So MJ is the largest side because it's across from the bigger angle. Then number 15, it says, now they're telling us that MJ is the smaller side. So let's add some numbers here. So let's say now instead, MJ, let's say it's 5, and LK we could say is 6. So now this time, the LKJ is the bigger angle because it's across from the bigger side. Then number 16, it says write a temporary assumption you could make to prove the conclusion. You won't have to do anything like this. So that was indirect proof, so you can skip number 16. You won't have to make a temporary assumption. Then number 17 says describe the possible range of distances from the beach to the movie theater. So again, here's where we're going to take the two numbers and add them and subtract them. So for number 17, we're going to do 9 minus 7, and then 9 plus 7, 2 and 16. So the distance from the beach to the movie theater, that range of values, it has to be greater than 2, but less than 16. Greater than the sum, greater than the difference, but less than the sum. And then number 18, I'll mark it as the same distance from your house and the movie theater and the beach. It says copy the diagram and locate the market. You won't have to do that. You won't have to copy a diagram. And chapter 7, this was our quadrilateral stuff. So in order to find the value of x here, I know that this this is a 1, 2, 3, 4, 5-sided figure. So the first thing I need to do is figure out what the sum of the 5 angles of a pentagon equal. And I use my formula n minus 2 times 180, where my n value is 5. So 5 minus 2 is 3, and then 180 times 3 is going to give me 540. Now what I need to do is I need to take all of these angles and add them. So I'm going to do x plus 103 plus 122 plus 98 plus 99 and set that equal to 540. It doesn't matter how you write down those angles. If it doesn't ask you for something algebraic, you can just add them and then subtract. So I get 422. Subtract that from 540. And I get x equals 118. For number 2, I'm going to do the same thing. Notice I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. So I have to do 8 minus 2 times 180. You could also count how many angles you have. That could be your n value. Either way, the number of sides and the number of angles are always the same. So 6 times 180. And I get 1,080. Let's see. 1,080. Now I need to add all of these things. So I'll start here at the 90 first. So I'm going to do 90 plus 166 plus 150 plus 143 plus 112 plus 94 plus 5x plus 170. And then I set that equal to the 1,080. So I need to add up all of these numbers. So I can just put down my 5x so far, but let me go ahead and do all that addition. So once I add all those that I highlighted, I get 925. I need to subtract 1,080 minus the 925. Five x equals 155. Divide by 5, and x equals 31. Then number 3, these are all exterior angles. So what I need to know is that the sum of the exterior angles is always 360. So I'm going to add 82, the 59, the 47, the 36, and the 65, and the x, and set it equal to 360. So x plus 59 plus 47 plus 36 plus 65 plus 82 and set it equal to 360. Go ahead and do that addition. Add those, I get 289. Subtract 289 from the 360, and x equals 71. For number 4, it says in parallelogram EFGH, angle F is 40 degrees greater than G. It says sketch and label each angle with its correct angle measures. Explain your reasoning. All right, so we don't need to do this one as well. I'm not going to make you sketch anything. Now, for number 5, it says, are you given enough information to determine whether the quadrilateral is a parallelogram? So notice here, I can see that I've got one pair of opposite sides that are, or opposite angles that are congruent, but I need to have both pairs. So this one, because I don't have anything here or here, I can't tell that those angles are congruent or not, and I'm also not told that the lines are parallel. So this is not enough information. Now this next one, because my diagonals have been bisected, I can use my parallelogram diagonals converse to show that this is a parallelogram. And then the next one. Okay, so for the next one, all I'm given is that these opposite sides are congruent and the other are parallel. Now, if the parallel marks would have been on the sides that were congruent, then I could say that this is a parallelogram. But the way it's pictured, it is not a parallelogram. It could be a trapezoid because trapezoids have exactly one pair of parallel sides. So this is not enough information. If the parallel marks were here, then it would have been enough information. The next one says list each type of quadrilateral. So if it's equilateral, we know that that can be a square or a rhombus because all sides are the same. When number 9, its interior angles are all right angles, and that is one of the properties of a rectangle. And then all squares are rectangles. So both squares and rectangles have 4 right angles. The diagonals are congruent. That is a property of a rectangle. And we know that all squares are rectangles. And then opposite sides are parallel. That was that whole flow chart I showed you. Remember that by definition, opposite sides are parallel for a parallelogram. And then we also know that all rectangles, squares, and rhombuses by definition are parallelograms, so all 4. All right, so you don't have to do this one as well. And then here it says one side of a quadrilateral JKLM is longer than another side. And it says suppose, okay, so you don't have to do this one either. Over here, it wants you to give the most specific name for this quadrilateral. Notice it only has one pair of parallel sides. So this would make this a trapezoid. And then number 15, we can see that we have opposite sides here that are congruent. And let's see what else we can do. Let's figure out this missing angle here. So once I add, because this is a little triangle here, so I can add 33 and 57 and get 90, and then subtract that from 180, and I can realize that these diagonals are perpendicular. So we don't have right angles, but we do have the perpendicular sides. So here, again, these angles here would have been bisected, so they're definitely not right angles. So it's not a square. So the most specific name for this is a rhombus. This one was the trapezoid. And then here, this is going to be, it has congruent consecutive sides. And again, see the congruent angles here. So then that tells me that the sides across from them are also going to be congruent. So the most specific name here is going to be a kite. All right, so here it says in trapezoid, WXYZ. So let me go ahead and draw that. So whenever you're naming it, go in order. So WXYZ, and it's telling you that WX is parallel to YZ. So these are the bases. And it says that YZ is 4.25 centimeters. It's giving me the measurement of the mid-segment. So remember, the mid-segment is going to hit here at the midpoints. And it's giving me a length of 2.75. So it wants me to find this other side of the trapezoid, this other base. So remember, what we're going to do here is we add the two bases. So remember, it was base 1 plus base 2. Divide by 2, and that gives us the mid segment. So I'm going to add, so I could just do x plus 4.25 divide by 2 equals 2.75. So what I want to do is get rid of the fraction first by multiplying both sides by 2. And when I multiply 2.75 times 2, I get 5.5. And then I still have the x plus 4.25. So then I can subtract 4.25 from both sides. And I get x is equal to 1.25. Oops. And this was centimeters. So that is it for all the problems in your study guide. So again, 35 multiple choice, 10 free response, and 2 proofs. One of the proofs will be a fill-in, where I either give you the statement and you give me the reason, or I give you the reason, you give me the statement, and then the other proof, you're writing the whole thing yourself. It will be a rather short proof, not too long, probably at most 4 steps. And I would focus not on chapter 7 for the proofs, because I would go back and review some of the earlier stuff for the proofs.